Today we're going to be talking about some of the vocabulary you'll need for Unit 7. Our first vocab word is term. A term can be numbers, variables or letters that stand for numbers, or a product of a number and a variable. So in this case, we're multiplying -1/2 times some number we don't know, t. Example of a term, we could have -3x. We could have a 4 by itself, or again, -1/3 times m. So these are all examples of terms. An expression. An expression is a group of math terms containing numbers, variables, and operators. Operators being addition, subtraction, multiplication, and division. An example of an expression, we have -4m plus 2. In this case, we have two terms. The -4m is one term, and another term 2. Now, one trick to remember expression does not have an equal sign. I always thought the x reminded me like it crossed off the equal sign, so it's only one side of our balance here. An equation. An equation is a math statement that shows the value of two expressions are equal. So as an example of an equation here, I have -4m plus 2 equals 14. Coefficient. A coefficient is a quantity or a value or amount placed before multiplying the variable in an expression. So if we looked at the expression -4m plus 2, -4 would be the coefficient. Now -4m is a term, but the coefficient would just be the -4. A variable is a quantity or number represented by a letter that may change. So in this case, -4m plus 2, the variable is m. A constant is a number that is on its own. So using the example -4m plus 2, the constant would be 2. A sequence. A sequence in math, a collection of numbers or terms that follow a particular pattern. So in this case, if they gave me 12, 1, 10, 2, 8, can you see a pattern happening here? So we can see to get from 12 to 10, we're subtracting by 2. And then 10 minus 2 gets us to 8, and so on. Here we have 1 plus 1 is 2, so my next number would be a 3, followed by a 6. A pattern is a repeated design or reoccurring sequence. So in this case, to get from 1 to 4 to 9 to 16, we have some number and we're squaring it. The distributive property. The distributive property lets you multiply a sum by multiplying each addend separately and then adding the products. So for example, if I had -3 times x minus 2. Now, PEMDAS, or order of operations, says I have to take care of what's in the parentheses first. However, I don't know what x stands for, so I can't do x minus 2 if I don't know that value. However, we can use the distributive property to multiply that -3 to both terms inside the parentheses. So I'm going to multiply the -3 times the x, and I'm going to multiply the -3 times the -2. -3 times x is -3x, and a negative times a negative is a positive, so 3 times 2, we have 6 here. the associative property. This property lets you add or multiply regardless of how the numbers are grouped. So if I had 3 plus 4 in parentheses plus 2, if I moved the parentheses so they were around the 4 and the 2, I would end up with the same answer, even though I changed the grouping. So 3 plus 4 is 7, I still have to add that 2, or 4 plus 2 is 6, I still have to add that 3. Either way, both of these are coming out to 9. So again, this is only if all of our problem is adding or all of it is multiplying. A trick I use to remember associative property, the SO, it has the same order. The order of my numbers didn't change, just the grouping or the parentheses moved. Our last term is the commutative property. The commutative property lets you add or multiply, and the order does not matter. So if I had 3 times 4 times 2, I would get the same answer if I did 3 times 2 times 4. 3 times 4 is 12, still need to multiply by 2, or 3 times 2 is 6, still need to multiply by 4. Either way, I'm getting 24 as my answer. My trick to remember this, the CO reminds me that I can change my order, commutative property.